Cool. Hello, everyone. If you'll find your seats, I'll go ahead and get started. It's just about 2 o'clock. Cool. Sweet. Hi. So my name's Lisa Neigut. I work as an Android engineer at Electric Objects. Today I'm going to be talking to you about Artfully Embedded Android, basically how we've taken art and put it onto an Android device. But to start, I'd like to talk a little bit about who we are. So Electric Objects started as a Kickstarter project in early 2014. We were founded with the express goal of creating a permanent screen for digital art. So about a year later, we're a team of 8 people. We're in New York City, and together we're building this computer for art. So what is the EO1? My slides are slow. So our first prototype that we're building is called the Electric Object 1. We call it the EO1 for short. So if you hear me refer to that, that's I'm talking about the computer we're building. It's a custom designed and built embedded computer. I've brought one with me to show off today. That's what's here on the podium. Cool. So the EO1 at its most elemental is basically like a board and an IPS LED screen. It has 2 capacitive touch sensors and a light sensor. The EO1 has no touchscreen or keyboard, so any inputs that you have to it have to be basically wireless. The board itself is a 1 gigahertz dual-core ARM board. It's got a 2D and a 3D graphics card, 1 gigabyte of RAM, 2 gigabytes of flash memory. There's an onboard eMMC drive that we load the operating system into. And as mentioned before, there's no touchscreen, there's no inputs. So while the original prototypes ran Raspberry Pis with Linux, we shifted to Android for production builds. The current prototypes ship with KitKat, which is Android 4.4. We're downscale. The reason we're on 4.4 and not Lollipop is that we're downstream from our board manufacturer, so we're waiting for Freescale. If you go back a slide. It says so the first line, dual ARM Freescale board, we're downstream from Freescale, so we're waiting for them to approve Lollipop to run with the boards, and then we can start moving our version of the operating system over to it, which is cool. So the setup configuration, basically getting it onto the Wi-Fi, you do using your personal smartphone with Bluetooth. It talks to both iOS and Android devices. Artwork is loaded via Wi-Fi then. Again, there's no touchscreen, so everything that you do with it has to be basically wireless, which is by design. Cool. So that's a little bit about the EO1. Let's talk a little bit more about the artwork. So the EO1 was built basically to do one job, to provide like a permanent space in your home for digital art. The kinds of artwork that we support, there's currently 3. There's static images such as PNGs and GIFs, PNGs and JPEGs. You can load up a web page into it, so anything that runs in a browser, you can point basically the EO1 to it and it'll run it. And so how are we doing this? The EO1 is basically running an Android application on top of the operating system. So for static images, we load the image over Wi-Fi and then display it in an image view. A web page we're loading into a Chromium Webview, and then we have GIFs. The Chromium Webview is kind of cool. We're using a project called Crosswalk, which more closely mirrors the Chromium builds, so it's more closely tied to the releases that Chromium does. Since our OS is KitKat, and since it's not a Google approved device because we have a separate operating system, we're not able to we want to have our web view more up to date than KitKat's, which is why we're using Crosswalk. Cool. So let's see. Let's take 2 seconds. Okay. So if you notice, I didn't talk very much about how we're doing GIFs. GIFs are really ubiquitous on the internet. We get a lot of artwork, a lot of users uploading artwork that is in a GIF format. But there is no GIF decoder that's included in the Android SDK natively. So this is a bit of a problem. Let's go backtrack a little bit. So let me talk a little bit about what a GIF is. This file format was created in 1987, so it's pretty old. GIFs are difficult to run and to run well. So when I started at EU in January, GIF performance was our biggest problem. So what follows is a quick history of the different things we've tried to get GIFs to run and run well on our hardware. So the first thing I wanted to understand when I got there is why some GIFs looked really good and why some GIFs looked really terrible. So we had this GIF, as you can see on the left. It's called Plants. It's by Erica Gorachow, who's one of the artists that we're working with. It was running pretty well on the implementation that we had, but not the best. So I got curious about exactly why some GIFs were running good and why others weren't. Basically, when you look at the file format, an animated GIF is a bundle of several frames. You can use image magic and point it at the file, and it'll print out stats about the GIFs. In this one, I got it to print out every frame and then some stats about the frame, about each frame. So just to kind of like look into this a little further, let's look at the 7th frame. So here's it zoomed in. The first thing that you see is the name of the file. It's plants.gif, and then a number 6, so that we're looking at the 7th frame. Then it says the file format. The next set of numbers is this area. Is the area that's going to be updated for this particular frame. So there's 459 by 135 pixels that this particular frame is changing. The next set is the full size of the image. So this is a full size image, 1080 by 1920 pixels. And then the coordinates for where the updated frame like drawing is going to occur at. So you can see for this frame, the amount of the screen that we're updating is actually fairly small. And when you look back at Erica's GIF, you can see how the amount of the frame that's updating on every pass when it animates, how that would be fairly small. Because the only thing that's moving in this case is the fly. So as you can imagine, getting this GIF to run fairly well. Oh, it's not playing. Yes, it is. Sorry, it's not playing, is it? Yeah, it's playing. It's just playing really slowly. Okay, so you can imagine that the performance of the GIF on the left would be better than the one on the right. So it's not animating really well. I think it's because I'm running a lot of stuff on a machine right now. Hang on, sorry. See if I can get it to start. Yeah, okay, it's not moving at all. But basically, this, I can describe how it looks. The circles of color are moving upwards. So every single, when you unpack this GIF that David made, every single pixel is getting updated on every single frame. So this is one of basically, that's the most pixels that you could basically throw at the frame buffer every time to redraw. So this piece, it's called Boca Raton, became the litmus test for our GIF players. So now that we understood, okay, this is kind of what we're working with. This is like going to be the hardest GIF that we can get to run on this thing. What are our options? So we tried a couple different things. The first thing that we tried was basically using this media player hack to play a GIF. It was smooth in that there weren't any drop frames, but it was really, really laggy. GIFs didn't scale well in it, so you got really grainy artifacts in it. I think it was in like the 5 to 6 frames per second range. For reference, David's piece should run at about 30. Cool. And then there's the code, kind of what it looked like whenever we were using the media player. The next thing we tried is we wrapped GIFs in an HTML wrapper and just rendered them using the WebView, so using the crosswalk WebView. The WebView ships with a Jiff decoder in Chromium, so we were trying to take advantage of that without having to like use another one, find one for Android. It worked pretty well. The problem with using Chromium is that it seemed to take a while to warm up. So you would load you'd load an animated GIF, and it would kind of be laggy and jump for the first like 30 seconds to maybe a minute, maybe 5 minutes, kind of depending on what you loaded. And after that, it would start running fairly smoothly. This was kind of a deal breaker for us. At the time, we were doing pay-by-piece artwork. So the idea is we'd have a store, and you would preview artwork, and then after previewing it, you'd make a decision whether or not to buy it. If someone's previewing it, you don't really have 2 minutes of them before they switch to the next piece to try it out. So we needed something that didn't have that warm-up time. Another thing about using Chromium is so the media player, whenever it gets behind a frame, it schedules the next one and it shows it. So the visual artifact that you get is that it's just slow. the Chromium Webview would drop frames whenever it missed them. So it would keep the animation time steady, but you would it would be very jumpy because whenever the rendering engine couldn't keep up with a frame, it would just drop it and go to the next one. It's cool. I think the fastest we got on this one was maybe in like the 10 to 11 frames per second. I apologize, I don't have better stats on that. The next thing we tried is using a Jiff decoder, which was in Java. We used Glide. It was smooth, there were no drop frames, but it was the slowest thing that we tried. My GIFs aren't playing. When it got up to speed, so out of the box, the fastest we could get David's piece to play on this was about 3 to 4 frames per second, which is like a 1/10 of the speed that it's intended to run at. So that wasn't going to work. So finally, we went native. We found this open source library that wraps a native C GIF decoder into an image view using a GIF drawable. It worked pretty well. But David DeSandra's piece, Bogaraton, which was our litmus test, was still noticeably slow. There were also some artifacts with like tearing. Basically, like half the screen would update before the other half did, so the frames would be like kind of jumped. It's hard to explain. Cool. So this was pretty good. This was a lot better than we had prior to that, so we were pretty happy with it. So I started kind of like got curious about, okay, why is this slow? What's going on? How can we make it a little bit faster? So it turns out there's this handy Python script called Systrace that ships with the Android SDK. It helps you analyze the execution of your application in the larger like Android environment of what's happening on the entire system. It lets you see system and application process execution on a common timeline. And importantly for us, it gives you visibility into surface flinger loops. So here is a 10-second Systrace of the EO1 running the full size, that's 1080p GIF, the Boca Raton one for David, using the Android GIF drawable as we found it. So let me break this down a little bit. At the top, you'll see our 2 CPU cores, because it's a dual core processor, so it's CPU 0 and CPU 1. And then the colors of the bands of color are the different threads that are operating on the CPUs at that time. Underneath that is each process. So at the bottom, we have the process the electric objects.app is running in. It's down here. And then in the middle is like the system level UI process that's managing the graphics queue. It's got 5 binders in there, a Vsync thread, and in the middle, this really big piece here, this is the surface flinger. So roughly, these surface flinger like events correspond to the frames per second that you're seeing. And you can see in this one, you can actually like count them or whatever. There's about 8 to 10 frames per second on this. So this is, again, this is the 1080p, so full size, running on the Android GIF drawable library, which is cool. So then, just in the sake of experimentation, we asked David to make a smaller version of it. So instead of doing 1080p, he cut it down to 720p. And you can see the frames per second pick up pretty appreciably. We're closer to 12 frames per second here. But we still kind of needed a faster way of getting pixels onto the screen. So you can see the surface flinger beats are like closer together than the previous one, which is cool. Cool. So in order to do this, I started digging into what exactly is in the Android graphics pipeline. Came up with this lovely drawing. Basically, what this is showing is how a buffer, so the Android screen is basically kind of composed of buffers and different applications. So like your application will get a buffer from the hardware composer, which is this line down here, and pass it to your app. And your app will basically fill in that buffer with information like drawing instructions. Basically, it's like a big bitmap that it's rendering from all your draw code. And then it passes it back to, when it's done with it, it passes it back to the surface flinger. And the surface flinger will composite that with like pieces from the system UI. Pass those to the hardware composer, which then pushes it out to like the frame buffer on the screen. This isn't enough detail really to figure out what's going in my application though, right? What I'm really interested in is that little red box in the corner that's got the app on it. So here's a rough approximation of how the render pipeline works. This is based on like KitKat, which is what EO1 is running. So basically, you start in the top left-hand corner with the image view, and it's got a GIF drawable running in it. the very beginning, we start with like this Jiff that we've downloaded from the internet, which is like a big array of bytes. We're passing it to this C library called Android Jiff Drawable, and then it's more or less passing back bitmaps to the image view. When it passes a bitmap back to the image view is going to call invalidate. It's basically invalidating the image view. So what that does is basically it calls schedule traversal on the view, which goes all the way up the view chain, and when it gets to the top, it calls out to this thing called the choreographer. Now, the choreographer is tied to this concept called Vsync. Vsync is tied to, so in graphics, when you have a screen, the refresh rate on the screen is usually like 60 frames per second, more or less. And that's as fast as the hardware can actually refresh. So that's the most, basically, most times that you could update the screen. Vsync is tied to the hardware of the screen. And whenever that refresh, like basically the hertz rate, whenever that updates, it sends out a heartbeat to the choreographer. The choreographer waits until it gets this next. So you invalidate, you schedule a traversal, which is basically flagging to the draw system, hey, I need to be updated. So the choreographer kind of puts it in a queue and waiting for the Vsync heartbeat. So the next time this screen refreshes, it triggers a perform traversal. It's like, okay, ready, set, go. You have like 16 milliseconds before the next frame rate is going to happen. Try and get all of the pixels into the frame buffer before that happens. So it's going to trigger perform traversal on the view class, which more or less it builds these display list objects, which are kind of abstracted OpenGL. Well, it depends on what your renderer is, but it's basically like a set of drawing instructions. So in this case, it's going to build a display list. It's going to go to the image view. It's going to request that bitmap that we've updated. Pass that down to this OpenGL renderer, which is going to compose it into a frame buffer, which then gets pushed to the surface flinger. Cool. So you're kind of driven by this Vsync event here. You're waiting for them to get pushed before you can push the bitmap that you've pushed to the image view down to the surface flinger. There's a different pipeline that you can take, though, which takes out a lot of that. This is using a texture view. So instead of waiting for a Vsync event and going through a display list object, you can get direct access to a buffer using a surface, which is provided to you through the texture view. So now, instead of waiting for Vsync events, you basically get direct access to the buffer, which is what we ended up doing. So now we're using Android Jiff Drawable Texture View Edition. So when you look at the Systrace of the texture view version, you can see we're almost getting 30 frames per second on the 720p version. So this isn't quite full size, but it's close. And that's about at the animation rate that we wanted it to be at, which is great. Super exciting. So on the left here, we have 720p from the first time using the image view wrapping a GIF drawable, and now with 720p using the texture view. A lot better. So right now, we're actually working on optimizing the code in the C library to get it to run faster using more like code style optimizations than pipeline optimizations, which is cool. So what are we working on now? We've kind of decided that we've like slayed the Jiff dragon, which is really exciting. We're working on getting video support into the EO1. So that will be rolling out in our May builds. We've started getting prototypes. Well, we started like some very early kind of prototypes for getting OpenGL shaders to run natively on Android. It's probably going to be a few more months before we get this out. The basic idea is giving artists or people who do visualizations the ability to write a shader, which is an OpenGL kind of program, and then upload that as a file that would then get loaded by the EO1 over the network. And then we could take that set of instructions and run it in OpenGL and do that without having to expose or download an Android app like separately. So that's like kind of like experimental stuff we'd like to do. And then there's a lot of really great generative artwork that exists for Android that's built using apps like Unity and other frameworks that would be really exciting to have on the EO. So that's like probably a ways out, but definitely something that's on our roadmap. Cool. So couldn't not say that we're hiring. We have 2 open engineering positions at the moment. One's called artwork engineer, which would be someone who's working on problems like this for the GIFs, and kind of liaisoning between the hardware and Android and the artist community that we're working with, helping them get what they want onto the machine. And the other one is a device API engineer. We really need someone to like lead up our back end for how our EO1 is like talking to the network. So come talk to me if you're interested in applying. So that's it. Thank you. I'm happy to take questions, and I guess I can take a few minutes and demo this if you've got like a second. So cool. I'll go ahead and show you this. Cool. So I've been having some trouble with the Wi-Fi. If it's still on the network, like part of our design philosophy is that we I don't know if it's gonna work. Part of our design philosophy is that the device only shows artwork. So notifications are like, hey, I'm loading your artwork, or I'm offline, don't show up on the device right now, which makes it kind of hard to debug, but it means it always looks nice. Cool. I don't know if that's gonna work. Anyways, yeah, question.
Would it be possible to play a GIF in the background before showing it to the user, or does it?
Update, cool.
Should I ask the question again? Okay. Would it be possible to play the GIF in the background until it renders before showing to the user, or does it lag, or does it affect the performance?
I'm sorry, I don't understand what you mean by play it in the background.
What I mean is, in example, you play a GIF in front of for the user, and the next preview one loads in the background. I don't know if it's possible, or if it's possible just to render it.
So the question was about preloading artwork, so have it loaded before the user clicks on it. The problem with doing that is that, as you can see, there's quite a decent number of artwork in our library. So predicting what someone's going to click on before they click on it is really difficult. We have added a cache to the device. So if I pick a piece that I've already viewed recently, it won't reload it from the network. It'll load it locally from the cache. So we're caching after the fact, but not ahead of time. I don't know if that updated. Anyways. Cool. Yeah.
Do you consider like converting the GIFs to anything, and were there considerations?
Totally. So if you noticed on our what's coming next is video support. I think videos are going to be the way that we start pushing more people. And honestly, a lot of artists really can get a lot more. There's more colors you can put into an image format. They run better. I'm not sure if they're smaller or not, but that's definitely something that we're pushing, and it'll be coming out by like, I think, May. The reason we didn't, I'm not really sure what the reasoning was for doing GIFs before we did video, if that makes sense, like why one instead of the other, but we're definitely going to start pushing people more towards video just because it's a better format, and it plays like beautifully. There's like no problems. So like the native Android decoders like work great, which is really cool. The cool thing though, I will say about having done GIF first, is that if we had done video first, I'm not sure we would have put this much effort into making the GIFs look great, if that makes sense. And a lot of the art on the internet is GIFs, right? So for people who like, you find a great GIF, you want to like upload it to your EO, like it's really like, it's great that we have like a pretty solid player for them, which is cool. Yeah.
I know you touched on it a little bit, but I was curious if you could elaborate more on why you guys decided to go with an Android system and over the embedded Linux solution.
Yeah, totally. I think that basically it came down to engineering resources. The engineers that they had at the time were Android devs. And the reasoning was that it would be easier to find people to work on an Android system than it would to find people who would work on a Linux system. Was one of the like large things. Another thing about it is like a lot of the view frameworks are already done. So like the crossfading between the different view types is really easy to get in Android. It's just like a fade animation. So the framework's kind of already built for doing a lot of display stuff, which I don't think was necessarily the case for Linux, I came in after Android was like established, so I'm not 100% sure on those, but cool. Yeah, totally. Cool. Yeah, they're already on sale. We're doing pre-orders for September right now. They're $399. That's cool. Yeah.
So are you running like a custom flavor of Android then? Like auto starts an app? Like how does it work?
Yeah, totally. It is so basically the app that we're running and that did it update? Yes, it did update. The app that you were running for this is a launcher app. So it's the only launcher app on it. So basically, when it starts, it's what gets kicked off as a launcher, which is how we kind of like did that. Yeah.
It's not an Android question, but how can artists participate in this project?
Yeah, that's a good question. I think the best thing to do is to get one and then start playing with it. Anyone can upload artwork to the system. So if you have like a Jiff or if you have a like static image that you wanted to try out, or if you had like a website that you wanted to show off, it's hard to like load. But basically you can get one and then like you can do all of your artwork and upload it and see how it looks. That's like looks good. Yeah, totally. So I think the biggest modifications that we made to the Android operating system was all the touch little pop-ups that come up for Android. So one example would be whenever you hit the power button and hold it, like the power, like there's like a dialog that pops up and asks for input. And so we had to figure out a way around that. A lot of what we ended up doing is like using other keys that aren't hardwired to like dialogues and the like. We didn't actually do like a whole lot of modifications to it, but most of it is because Android expects you to have like a touch screen. It's turning off everything that's related to anything that you can touch. Because if that shows up, like the user can't touch it, it's just like ruins the whole artwork experience, which is cool. Yeah, I think there was a question there.
I was wondering if, using the pipeline without the vertical separation, have you seen some artwork, some clearing effect? Or?
I haven't, no. And to be honest, I'm not the one who implemented it, so I think you still get some of the benefits of using the Vsync. It's just that you're not waiting for that trigger to go, and you've taken out a lot of the going through like all the display lists to draw it. You can just draw directly to a buffer, if that makes sense. Yeah.
For the solution, for the hardware solution, how would this differ from a Google TV connected via HDMI to display?
Yeah, that's a good question. I think the biggest difference is going to be the screen. So this is an IPS LED, which means that it's got really nice blacks. It looks good from different angles. You could basically do the same setup, and I know there's people who are working on doing things for like Chromecast. Like a lot of people already have TVs. There's a lot of logic that's like, oh, why do I need another screen for artwork when I already have so many screens in my house? My response to that is like, look, like where do you put a TV in your house? Like for most people, it's at a good angle for sitting at the sofa and watching it. Usually the screens are kind of like have a gloss on them, so it's a glare when you get at a certain angle. And they haven't really been like vetted or made so that like there's no notifications or distractions or anything whenever the artwork is showing, which I think is like how the EO is different. Yeah, yeah, totally. I didn't know. That's a good idea though. Yeah, I'll totally look at that. That's like interesting. Yeah, I don't know what it's. I actually don't. When did art? I don't know if art came out. I feel like art came out after Kit Kat. Maybe I'm wrong about that. It was experimental. Okay, but thanks. Yeah, I'll definitely look into that. That's a good idea. Cool. Yeah.
I don't know much about display technology. Is there a burn-in issue or anything like that, having that on all the time with the same image?
We haven't.
Something else?
Yeah, we haven't seen it. I don't know enough about screen technology either to answer that definitively, but I think we're okay. I think the burn-in problem was with plasmas, and this is LED, so you get away or LCD. Yeah, you get away from that a little bit. Yeah.
Do you have any specs on the, I guess,
Yeah, it's 59 hertz or 59 frames per second. Yeah. It's cool. You can get a lot of stats about your graphics pipeline using some like dump sys on the surface flinger. And that's one of the stats that comes up, which is cool. Sweet. All right. Well, thank you so much for your time. If you have any questions, I'll be here. I also have stickers if you're interested. Thank you.